All right, welcome back everybody to our series where we are going to be implementing every sorting algorithm there is in Swift. Now today we're doing something a little bit different. Typically what we're doing is we're going through each algorithm and we're going to teach you how to implement it and the pros and cons of it. But it turns out that not every algorithm has pros to it. In fact, today we're going to be doing the worst sorting algorithm, at least that I could find. If you know a worse one, let me know in the comments below. Now that sorting algorithm is called Bogo Sort. All right, before we go forward, I just want to remind everybody this is for beginners, so this should be easy to follow. But in this case, we're going to be covering stuff that really does build on previous episodes. So if you haven't watched any of our previous episodes on sorting algorithms, and you're getting a little lost or confused on this episode, feel free to go back and check those out. That said, we're still going to move forward considering that you're a beginner and we're going to explain everything in detail. Now, if you remember from previous episodes, typically with a sorting algorithm, there is going to be pros and cons. It's going to be a description of what the algorithm is good for, how to implement the algorithm, and usually there's an illustration, maybe an animation, and we talk a little bit about it. Bogo Sort is different from the other algorithms, and let's show you why. So if we scroll down here, you can see this is the algorithm. While our list of items, or in this case they call it a deck, while our deck is not in order, shuffle the deck. That's it. That's the algorithm. Do it over and over again. Keep shuffling until randomly you happen to get a shuffled deck that is in order. Now, hopefully you can see without any further description why this is a terrible sorting algorithm. If not, over the course of this episode, you will see. So let's start with a Swift playground. We're going to do the blank template here as always. And again, we're going to steal code from our previous episodes where we go through and we create a list of random numbers. The one thing we're going to do differently this time is we're going to make it a very small list, and you'll see why. All right, let's get to the algorithm. While numbers.isSorted is false, numbers.shuffle. That's the algorithm. Now you might think, oh, well, that's the end of the video. But as I promised in the beginning, there is stuff to actually learn from implementing Bogo Sort. Now, one thing you might notice here is Xcode is already complaining about isSorted. And that's because arrays don't have an isSorted function on them. And it kind of makes sense because arrays can hold all sorts of things. And so how would an array know if something is sorted for every possible thing that you could put inside an array? So what we're going to do is we're going to introduce an isSorted function on arrays using something called extensions. Extensions are a feature in Swift that make it so that you can extend the functionality of an existing type. In this case, the type that we're going to be extending is the array type. All right, we're going to have an extension of array where, again, not just any array, but where the elements in the array are integers. And that's important. Now, if you're a little bit more advanced and you already know about the comparable protocol, you'll probably recognize that this could be implemented on anything that implements comparable. But because we're trying to keep it simple, we're going to make it so it's only on integers. Now, if you've seen our other episodes, you'll know that this looks like a class declaration, and it is similar. We can go ahead and just put this function right here in between the curly braces on this new line here. And we're going to name our function isSorted, and it returns a Boolean indicating whether the array is sorted or not. Now you'll see that Xcode stopped complaining about numbers.isSorted and is now complaining that our function doesn't do anything. So we're going to do for I in self.count, and you will remember from our previous episodes that I is just a stand-in normal variable name for an index into our array. Now the other thing that we will do that's from a previous episode is instead of going from 0 through self.count, we're going to start at 1, and that's because we're comparing 2 items at a time. And so we're going to use I as an index into the array, but we're also going to use I minus 1. Now the last thing here is self. Now self, because this is implemented on a function in an array, self is always going to apply to the array. Now self always applies to whatever scope you're working in or whatever class you're working in. And so in this case, if we do like self and then we go subscript I minus 1, self subscript I, we're saying self, being the array, compare the 0th item with the first item, for example, in the first pass. And then the second pass will be comparing the second item and the third item, and so on and so on and so on. It's going to compare all of the items in the list. And so a way to determine if an array is sorted is to go through and compare them 2 items at a time, side by side. And if they're ever out of order, then you know that the array is not sorted. And if you make it all the way through and they are always getting bigger than each other, then the array is sorted from smallest to highest. So in this case, what we're doing is we're just checking, is the I minus 1 index bigger than the I index? If it ever is, then we can just return false, because we know that our array is not sorted. Now Xcode is complaining because we return false here, but it is possible to go through the entire array and never come across something that's out of order. So we just need to put a return true here so that no matter what, our function always returns either true or false, whether it's sorted or not. And in this case, this is part of the design of the function that we're going to go through every index. We're going to compare the 2 items side by side, and if they're out of order, we return false. And if we make it to the very end and we've never reached something that's out of order, then we return true. Okay, so now you will notice that nothing is complaining and our algorithm is working because we've provided this extension. So let's go ahead and print numbers here at the bottom and press play, and we'll see it comes out with the sorted list. There we go. And that wasn't too bad, right? For such a simple, easy to implement algorithm, you know, think, well, that was decently fast. What's the problem here? Well, I'm actually curious then, how many times did it shuffle the deck to get 4 items in order? Now this is where we're going to go ahead and we're going to show you how to do some performance metrics. So if we just do print numbers here, it's going to go through and it's going to print every single step it took to shuffle. Now in this case, it's a lot. This is a whole bunch of steps. It's not always going to be that way because it's a completely random algorithm. So let's go ahead and let's actually, instead of printing out these steps, let's count the number of steps it took. Now, a computer science-y term for the number of steps something takes is the number of iterations, or the number of times it had to go through this list. So we're going to say variable iterations equals 0, and then every time we do an iteration of this little loop here, we're going to add 1 to that variable, and then when we get to the end, we're going to print out the iterations. So this is one way of tracking how efficient our algorithm is. It makes it so that we can see, in this case, our array was sorted first try. Well, that's probably not always going to be the case. So let's stop and run it again. Okay, this time it only had to shuffle once. Again, once, twice, 4 times, 78 times. And that's why Bogo Sort is just such a problem, is for 4 items, if it was always 1 or 2 shuffles and you could get there, no problem. But if you're just shuffling, there's no way to predict that you didn't shuffle poorly 78 times in a row. And to really show you this, let's go ahead and introduce time profiling. Swift has a type called date. And if we do date and we just initialize a new instance of date, what this does is it actually grabs the current date and time, which is awesome. Because then what we can do here at the end is we can print, again, grabbing the current date and time, and we can say what time has elapsed between the current date and time and the previous date and time. So up here we have a variable that holds start time, and it's going to just be a date and time object. We're going to do our algorithm, and then we get to the end, and we're going to grab the new current date and time after we've run the algorithm, and we're going to see how much time has elapsed since that start time. So let's run it. So now you can see 4 iterations and 0.03 seconds. That's not too bad. Let's scroll up here though, and let's throw a wrench in this. Let's change this number from 4 to 7. Just increase the opportunities for the randomness to take its toll. Already we're up to 1,060 iterations and 0.1 seconds. That's a big change. Let's run it again. 5,500 iterations and almost half a second just to sort 7 items. Now, we clicked the button, it looked like it went really fast, but what happens if we go to 8? How much worse does it get with just adding one more item to the list? As you can see, a lot. 28,000 iterations in over 2 seconds. Let's dial this up to 10. All right, now as you can see over on the right hand side, it's just ticking away. Let's go ahead and let's expand this sidebar a little bit here so you can actually see the date and time there. All right, well, I guess we'll just keep this running. Thanks for watching. We appreciate you tuning into this episode, and hopefully you learned a little bit about profiling your algorithms, understanding how many iterations they take to go through them, how long they take to actually run your algorithms, how to extend types, including classes and structs, and finally, how to implement the Bogo Sort algorithm. If you enjoy these episodes, please like and subscribe. It really helps the channel and it helps the videos as well. And we'll catch you next time when we continue our quest to implement every sorting algorithm in Swift.